Now we are going to start fault analysis. Now the very first question here is, what is meant by a fault? Okay, so fault is anything which interferes with the normal supply of the electric power, right? Fault refers to any failure interfering with normal flow of power or current. Now faults can be either transient in nature or they can be permanent. Okay, so transient is something which occurs momentarily, okay, and they will be auto cleared by means of auto reclose circuit breakers. Okay, it doesn't need specific attention. But other faults which are permanent faults, what happens here? They cannot be automatically cleared by circuit breakers. Okay, so you can write down here, faults can be either transient or permanent. Now transient faults, they are usually caused by momentary short circuits or lightning. So this will also cause some transient fault. Okay, so can be cleared automatically by auto reclose circuit breakers, and permanent faults cannot be automatically cleared. So here examples include damage to the tower or insulator, or the falling of transmission line. So these are all, they require attention, manual attention, they cannot be automatically cleared. So these are called the permanent faults. Okay, so this is, you can take it as one kind of classification, but the main important kind of classification that we are concerned with is the categorization of faults into symmetrical and unsymmetrical faults. Okay, so symmetrical faults can be transient or permanent in nature. Similarly, unsymmetrical faults can be transient or permanent in nature. Okay, so symmetrical faults includes a three-phase fault. So this is also called as LLLG, triple LG. That means all of the three lines are being short circuited with the ground. Okay, so that is why it is called a symmetrical fault. What happens in unsymmetrical fault? You have different types. First one is the single line to ground fault. So this is called as LG fault. Okay, so one line is short circuited with the ground. The second one is the line to line fault. That means two of the lines will be short circuited. So this is called as LL fault. Okay, and the next one is the double line to ground. That means two of the lines, they are short circuited with the ground. So this is called LLG fault. So you can see why this is called unsymmetrical fault and this is symmetrical fault, right? Here if single line to ground fault is there, then the other two lines, they are not going to have the same fault current that is there in this fault line, right? So there will be some imbalance that is produced in the three-phase system. So that is why it is called an unsymmetrical fault. One more thing here is the unsymmetrical faults are more common. Okay, so these are more common. But the symmetrical fault, even though it is less common, it is the most serious kind of fault. Okay, so here symmetrical fault does not lead to imbalance between the phases, whereas unsymmetrical faults lead to imbalance in phases. Okay, And one more important thing is symmetrical and unsymmetrical faults can be transient or permanent in nature. Okay. Now what do we do in fault analysis? What is the purpose of fault analysis, right? So what happens is the fault currents are calculated for different types of faults. And one more important factor is the location of fault. Okay. So at various location of fault. Now once the fault current is calculated, then what is done? We have to choose a suitable circuit breaker. Now this choice of circuit breakers, it is going to depend on two factors. The first one is the current flowing immediately after fault occurs. So what happens in fault? The current that immediately flows after the fault will be different from the current that will flow after 2 to 3 cycles. Okay, cycles in the sense we have frequency of power, right? So that cycles I am talking about. After 2 or 3 cycles, the current is going to be different. So the circuit breaker is going to take some time before it acts, right? And the current that it has to break will be different from the current that flows immediately. So that current that it must break, that also the choice of circuit breaker will depend on. Okay. So the current which the circuit breaker must interrupt. So this current that flows immediately after the fault, this is flowing only momentarily, right? So only for a few moments the circuit breaker has to tolerate this current. Okay. Now another factor that the choice will depend on is the current that it has to carry under normal conditions. That means when there is no fault. Okay. So current that the breaker must carry under normal conditions. That is when there is no fault.